Okay, everyone, today we are going to start lesson 1, and it deals with exponential notation. So your student outcomes for this lesson would be: students know what it means for a number to be raised to a power. That's outcome 1. Students know how to represent the repeated multiplication symbolically. And students know the reason for some basis requiring parentheses. So there's reasons when we're doing exponential notation that you will need parentheses, and other times you will not. So hopefully after you watch this video, you will understand the 3 outcomes for the lesson. So let's talk a little bit. So this first example here, it says 3 plus 3 plus 3 plus 3 plus 3. Think of it this way. When we add 5 copies of 3, so we have 5 copies of 3, we devise an abbreviation for this purpose because mathematicians don't like to write everything out. So instead, you could write this out as 3 times 5 because we're just adding it 5 times. However, if we multiply instead of add, if we do 3 times 3 times 3 times 3 times 3 5 times, the way to do that in an abbreviation is with an exponent as 3 to the 5th power, because you are multiplying 3 5 different times. So make sure you know the difference between adding and multiplying. And this is what we are going to focus on today with the exponential notation, which you are sort of familiar with when we talk about squaring a value or cubing a value. So for example, if I wanted to rewrite 3 to the 3rd power, I would just be writing it 3 times 3 times 3 because I listed it 3 times. If I wanted to do the abbreviated form or shortened form of 3 times 3 times 3 times 3, I would write it as 3 to the 1, 2, 3, 4th power. So this just involves exponential notation. Okay, so here are a few examples I'd like you to write down on a sheet of paper or in your notebook dealing with exponential notation. So it says work through examples 1 through 5 as a group. And we're going to supplement if we need to. So for example 1, we're writing 5 times 5 times 5 times 5 times 5 times 5. Well, there are 6 different times we wrote that. That's why it is raised to the 6th power right there. Here we have 9 sevenths, and we wrote that 1, 2, 3, 4 times. That's why it's raised to the 4th power. Also, you can see here that the 9 sevenths, we put that in parentheses. For example, 3, we wrote -4 elevenths to the 3rd power. Well, the opposite way to think of that is we're writing it 3 times. And as you can see, this one also had parentheses. Example 4, -2 to the 6th power, we would just write -2. And we should be writing it 6 different times because of that little 6, the exponent up there. Lastly, 3.8 to the 4th power, we should be writing 3.8 4 times. So what I want you to take from this is, in cases where the base is either a fraction, like we had here, or a negative value, like we had here, parentheses are needed. So please note, remember, anytime you have a fraction or a negative base, you must use parentheses. So this example, we had to use parentheses because it was a fraction. This example, we had to use parentheses because it was a fraction and it was negative. And this example, we had to use parentheses because it was negative. So those are things to think about as we're working through this lesson. So here is just more information I want you to think about. Basically, this is exponential notation. So anytime you have a value, anytime you have a value raised to a power, you repeat that value or base as many times as you need to. So if this value right here said, this value right there instead of n said 17, you would have to write x 17 different times. So the number x to the n is called x raised to the nth power, where n is the exponent of x and x is the base. So please note the x to the n power. This x right here is called your base. The n is called your exponent. So we're just getting some terminology and vocabulary out of the way. Like I said, here is your base, which was right here, the x, and your exponent is right there. You have seen this kind of notation before, and this is called exponential notation, and we'll be getting into that later on in this unit. So like I said, this classwork, we already talked about this. Remember, 5 to the 6th power would be rewritten as 5 times 5 times 5 times 5 times 5 times 5. 9/7 to the 4th power, as you can see, the 9/7 was in parentheses, and you're just rewriting that 4 different times. So what I'd like us to try to do is work on exercises 1 through 10. I will do 2 of them with you. So let's take a look here. So if we look at exercise 1, 4 is my base because that's what's being repeated. So the first thing I'm going to do is write my base. And then I see down here that it is rewritten 7 times. So 7 would be my exponent. So 4 to the, that doesn't look like a good 7, 4 to the 7th power. Let's also look at number 8. Number 8 is -1/14th. And we were repeating that 10 different times by multiplication. So remember, anytime you have a fraction or a negative sign, you need to put that in parentheses. So -1/14th, and I'm raising that to the 10th power. Why don't you try to work on the other ones on this page? Pause the video, and whenever you are ready to check your answers, please press play. And just note, like for example 2, you have to put in how many times it was repeated by the exponent. So pause your video, and when you're ready to check your answers, press play. Okay, so if we're starting to check our answers, exercise 2, we were repeating 3.6 47 times. So that's why I put a 47 there. Here, -11.63 has to be in a parenthesis because it's negative, and we're raising it to the 34th power because of that repetition. Exercise 4, 12 to the 15th, we're repeating it 15 times. Exercise 5, -5 to the 10th power. As you can see, we had to put a parenthesis there around the base because it was negative. Exercise 6 has to have a parenthesis around the 7/2 because it was a fraction, and we're raising it to the 21st power. Exercise 7, -13 had to be in parentheses because it's negative, and we're raising it to the 6th power. Exercise 9, x was my base, and I'm raising it to the 185th power. And exercise 10 says x to the n, so it would be going n times. We don't know what that is, so we're still using it as a variable. Okay, so now we're going to go over rules when the base is negative. So this is not in your packet, but you could be writing this down in your notebook or on a sheet of paper. So if I wanted to start off multiplying -2 times -2, the exponential notation would be -2 to the 2nd power. Well, if I would actually multiply -2 times -2, I would get a +4. Let's look at this next one. -2 times -2 times -2. Exponential notation is -2 to the 3rd power. If I multiply -2 times -2, I would get 4. And 4 times your -2 would have an end result of a -8. Next one. -2 times -2 times -2 times -2 would be the same as -2 to the 4th power, but if I wanted my end result, -2 times -2, I'd get a +4. -2 times -2, I would also get a +4, and when I multiply these two together, I would get a +16. Let's look at one more example. The last example is negative 2 to the 5th power because I was multiplying it 5 times. So negative 2 times negative 2 is 4. We have another set of negative 2 times negative 2 would be 4. And then we have this lonely soldier right here. So I would be multiplying 4 times 4, which is 16, times my negative 2, and 16 times negative 2 is negative 32. So now I hope that you can start to see maybe a relationship. So when my base is negative and I have an even exponent like I have here and here, my answer will be a positive value. However, let me get a different color here. However, if I have a negative base and my exponent is odd, then I will have a final answer that is negative. All right, so let's take a look on this next page. Exercise 11 states, will these products be positive or negative? How do you know? Well, you could actually multiply this out 12 times to see if you would get a positive or negative answer. However, you could refer back to what we just sort of discussed. If I have a negative base and my exponent is an even value, my answer, my final answer, will always be positive. However, if I have a negative base and I have an odd number, my final answer will always be negative. So like I said, even exponent, your final answer will be positive. Odd exponent, your final answer will be negative. And this only works when your base is negative. Anytime your base is positive, your final answer will always be positive. So the rules I just discussed here are only when I'll write that down for you, when the base is negative. These rules work. When you have an even exponent, your final answer will be positive. When you have an odd exponent, your final answer will be negative. Oops, I went too far. So if we scroll down a little bit, I want you to try exercise 12 on your own. You can pause the video, and whenever you're ready to check your answers, press play. All right, so exercise 12 had your base was negative as well. And if I look at my exponent, this time my exponent is odd. So since my exponent is odd, my final answer will be negative. Down for the next one, I have a negative base, but this time my exponent is an even value. So remember, when you have an even exponent, your final answer will always be positive. Because I highly doubt you want to work out negative 1.8 to the 122nd power without a calculator on your own. So if you can memorize these rules, it'll help you. Why don't you try to do exercise 13 and 14 on your own, pause the video, and whenever you're ready to check your answers, you may press play. All right, so for exercise 13, if it was stating that n was an even number, your final answer would be positive. And if n was an odd number, your final answer would be negative. Exercise 14, Josie is wrong because this negative 15 has to be in parentheses. Remember what I discussed at the very beginning of this lesson. Anytime you have a negative base or a fraction base, you make sure that you use parentheses when you're writing an exponential notation. Okay, so just to summarize a little bit, it says, why should we bother with exponential notation? Why not just write out the multiplication? Well, like all good notation, exponential notation saves writing. Like I said before, if I would give you negative 4 to the 2,000th power, are you really going to want to write out negative 4 2,000 times? Probably not. And exponential notation is used for recording scientific measurements of very large and very small quantities, which we'll get into this later on in this unit, which is something we use with scientific notation. All right, so here are some final thoughts or a little conclusion. Remember, when you have a fraction base, you have to use parentheses to make your notation correct. When you have a negative base, you also have to use the parentheses to make the notation correct. When you have a negative base, like I do here with an even exponent, your final answer will always be positive. And if I have a negative base with an odd exponent, my final answer will always be negative. So that wraps up the exponential notation lesson. Your teacher will hand you out your homework assignment. Whenever you are done, you can begin that and make sure you have it ready for tomorrow. And as always, ask questions. Thank you so much and have a great day.